Hello students, we shall now discuss module 2 in energy systems and its analysis. So having completed module 1 in energy and environment with subject code 17ME562, the elective subject, we shall look at module 2, which speaks of energy storage, energy audit, energy management, and finally economic analysis. So we shall look into all this energy storage, that is thermal energy storage methods, and in energy management we will look into the principles of energy management, energy demand estimation, energy pricing, and in energy audit we will see what is the need or purpose, methodology, how it is done, and economic analysis we will see the scope and how we are going to characterize an investment project, because when we have to make a choice between 2 or 3 projects, then we need to do proper economic analysis. Coming to energy storage, I can give one simple example. We have sunlight, we get solar energy, say morning from 10 to afternoon 3. That is the peak time for this solar energy. But normally we people, we will be using hot water for bathing application early morning 7, 8, because we need to go to the college, office. So this solar energy which we are collecting has to be stored, because that when it is generated we are not using at that particular time. We are using it at when we need it. So this calls for a storage system. This is a very simple example I am giving. I give simple examples so that you can relate and understand the concept in a better way. Similarly, the solar energy is not available in winter. So what we understand is energy storage is critically important to the success of any intermittent energy source in meeting demand. Like solar energy is the intermittent energy source. Similarly, wind energy is also intermittent resource. In a year there are 8,760 hours, but these plants, whether solar plant or wind plant, they hardly work for 25% of the time. But as a country, as a society, our energy demand is 24/7. You cannot say that I don't have energy demand in any particular hour of a day or in some part of a week or some part of a month. No. So energy systems, storage systems can contribute significantly to the meeting society's needs for more efficient, environmentally benign, means environmentally friendly energy use in building, heating and cooling, aerospace power and utility applications. So as a society we use energy for heating. In India we don't use much for heating, we use it for cooling, but in Western countries they use lot of energy for heating also. Then for aerospace, power and utility applications. So use of energy storage system. One more example I can give regarding this energy storage is we have got power plants like thermal power plants, hydel power plants. But sometimes what happens, during sometime the demand increases or demand decreases. There is something called base load demand, peak load demand. You get up early in the morning, everybody starts his light, fan, TV, a geyser, so the demand increases. Okay. Then everybody goes to the office. There, in house the demand will be reduced, and in the factory offices the demand will increase. And the curve is not flat for all the 24 hours. Okay. So sometimes there is peaking, sometimes there is base load, and sometimes there is less load also. But the power plants which are working, they don't work that way. Because if you take a thermal power plant or any gas turbine plant or diesel power plant, they work at certain loading. So if the loading is less than 50%, then the efficiency of the plant is affected badly. So normally these IC engine plants, gas turbine plants, the coal plants, they work better if when they load, they have load of 70 to 80% on the plant. Otherwise it becomes like underloading. I can give an example. If somebody, you are traveling by a car, okay, you want it to be fuel efficient and the cost should be less. So what happens in one car means 5 people should be traveling. Then only it is economical. If in a car only one person is traveling, then it is underloading of the car. Okay. So capacity utilization is reduced. And because the capacity utilization is reduced, the cost of travel will increase. I think you understand this example. Same logic applies for this energy industry also. So this energy storage advantages are it reduces the equipment size, more efficient and effective utilization of equipment, conservation of fossil fuels by facilitating more efficient energy use and for fuel substitution, and reduced pollution emissions. Okay. Now we shall look at industrial energy demand. So energy is demanded by utilities, it is demanded by industry, okay, from residential sector, and this like commercial sector, public, and the demand, it varies on a daily basis, weekly basis, seasonal basis. I hope you understand. When summer is there, then most of the people run their fans. Those who have AC, they will run the AC also. I think that is one good example. In summer also, we use this refrigerator to the highest capacity, so the requirement of electricity increases. Ideally, these demands are matched by various energy conversion systems that operate synergistically. Peak hours are the most difficult and expensive to supply. The peak electrical demands are met by conventional gas turbines or diesel generators, which are reliant on costly and relatively scarce oil or gas. See, this power what we buy at home, electricity, say it costs on an average 7 rupees per unit. But if you run it on you have a diesel generator, it will cost you around 20 rupees per unit. I am just talking about 1 unit. Just imagine what is your daily requirement. That is why these are very expensive. Energy storage provides an alternative method for supplying peak demands. Likewise, energy storage systems can improve the operation of cogeneration, solar, wind, and run-off river hydro facilities. So cogeneration means like a sugar factory is what you have seen. They produce sugar, and after crushing the sugar cane, whatever that solid material remains, they call it as bagasse. So that bagasse is burnt, dried and then burnt, and in a boiler, so that they produce steam, and using a Rankine cycle they produce electricity. So this is known as cogeneration. That is heat as well as electricity.